Good morning, grade 6. Welcome back to grade 6 mathematics class. Hope you all are doing great. Today, let's discuss the questions from exercise 4.4. This is in page number 57 of your textbook. The first 4 questions were already given as homework in the previous class. So today, we'll be discussing from question number 5. So question number 5 says, Danny visits a shrine after every 48 days. Mary visits after every 32 days and Vani after every 64 days. One day, they met at the shrine. After how many days will they meet again at the same place? So what is given in the question? It says that Danny visits a shrine after every 48 days. So if you count from today, if it is day 0 today, on the 48th day from today, Danny will visit the shrine. So again after 48 days, that is the 96th day from today, Danny will visit the shrine again. Then again after 48 days, that is the 144th day from today, Danny will visit the shrine again. So you see, Danny is visiting the shrine on every 48th day. That is, Danny is visiting the shrine on the days which are multiples of 48. Similarly, Mary visits the shrine on days which are multiples of 32. And Vani is visiting the shrine on days which are multiples of 64. So we have the multiples of 48, 32 and 64. A few multiples are listed here. Do you see any common multiples? 192 is a common multiple. Danny is visiting the shrine on the 192nd day. The same day, Mary and Vani are also visiting the shrine. So, when you have a common multiple, that means the 3 will be meeting at the shrine. Now, when will they meet at the shrine again? That will be the next common multiple. So, which is the next common multiple? 384. See, 192 is the least common multiple or the LCM. That means after every 192 days, they will be meeting again at the shrine. So, if they met on the 192nd day, they will be meeting again on days which are multiples of 192 or multiples of the LCM. So, the next time they will be meeting again at the shrine will be on the 384th day. So, Danny, Mary and Vani will be meeting at the shrine on days which are multiples of the LCM. So, if they met on the 192nd day, after how many days will they be meeting again? Another 192 days. So, is this clear to you? Let's discuss the next question. It says, find the smallest number which when divided by 18, 27 and 36 leaves a remainder 5 in each case. So, if a number is divisible by 18, it will be a multiple of 18. If it is divisible by 27, it will be a multiple of 27. If it is divisible by 36, then it will be a multiple of 36. So, if a number is divisible by 18, 27 as well as 36, then it should be a common multiple for these 3 numbers, right? So, you are asked to find out the smallest number which when divided by these numbers will give you a remainder 5. That is, you have to find out the smallest common multiple or the least common multiple of these 3 numbers plus 5. Because when you divide it with either 18, 27 or 36, it should give a remainder 5. So, the required number will be the least common multiple of 18, 27 and 36 plus 5. So, is that clear? You have to find out the LCM of these numbers, add 5 to it to get the required number. You can do that yourself in your notebook. Let's discuss the next question. It says, find the smallest number which leaves the remainder 5 when divided by 15, 20 and 35. So, if a number has to be divisible by 15, 20 and 35, it should be a common multiple of 15, 20 and 35. And you are asked to find out the smallest number. That is, you need to find the smallest common multiple, that is the least or the lowest common multiple of these three numbers. But it's also said it will give a remainder 5, which means you will have to add 5 to these common multiple of these numbers. So what is the required number? The required number will be equal to the LCM of 15, 20 and 35 plus 5. So first find out the LCM, add 5 to it to get the required number. So this is how you should go about this question. Now question number 8. It says Tushar, Aman and Akash start jogging around a park at the same time. Tushar finishes one round in 36 minutes. Aman finishes in 24 minutes and Akash finishes in 12 minutes. When will they meet at the starting point again? So there is this park and Tushar will finish jogging around the park in 36 minutes. So after the first 36 minutes, he will complete the first round. And again after 36 minutes, he will complete 2 rounds around the park. So that will be after the first 72 minutes. So Tushar can complete rounds around the park in time which are multiples of 36. That is 36, 72, 108 and so on. Whereas Aman can finish rounds around the park in time which will be multiples of 24 because he finishes one round in 24 minutes. And in the case of Akash, he can finish one round in 12 minutes and hence he can go more rounds around the park in time which will be multiples of 12. So here you have the multiples, a few multiples listed. Do you see a common multiple? Whenever you have a common multiple of time, that means they will be meeting at the same place. So let's see which are the common multiples of time here, and these will be the time points that they will meet each other. So here you can see common multiples such as 72, 144 and so on. You see the least common multiple or the LCM here is 72. After the first 72 minutes, these three people can meet at the same place. Again after 72 minutes, they can meet again. Again after another 72 minutes, they will meet again. So they will be meeting at the same place again and again after every 72 minutes, which means they will be meeting at the same place at times which are multiples of 72. So when they go for jogging on a particular day, after the first 72 minutes, they will be meeting at the same place. So is the concept clear to you? If this is clear, let's move on to the next question. It says, find the greatest number that will divide 130, 150 and 200, leaving remainders 2, 6 and 8 respectively. Here you can see three numbers are given, but the remainders are different in each case. So here it says when 130 is divided by a number, we don't know that number, we are asked to find out that number. When you divide 130 with a number, you get a remainder 2. So to get a remainder 2, what should be subtracted from 130? That would be 130 minus 2, that is 128. So if you subtract 128 from 130, you will get a remainder 2. And you see, what you write here will be a multiple of this divisor and the quotient, because you multiply the divisor and the quotient and you write the number here. So we don't know what number is here, but we know this number here will be a multiple of what you have written here, and hence this number will be a factor of this 128. Okay, and the same number, the same divisor or the same factor, when it is used to divide 150, when it is used to divide 150, you get a remainder 6. So what should be subtracted from 150 to get a remainder 6? That will be 150 minus 6, which is equal to 144. So here also this is the same divisor we are using here, but we don't know what that number is. But if it is 144 written here, it means it is a multiple of this unknown divisor here. Or here this unknown divisor will be a factor of 144. Similarly, if that same divisor or the same factor, the unknown number is used to divide 200. It says we get a remainder 8. So to get a remainder 8, what should be subtracted from 200? We should subtract 200 minus 8, which is equal to 192. So if you subtract 192 from 200, you get a remainder 8. So this means that this 192 is a multiple of the number here, the divisor here, or this unknown number is a factor of this 192. So you see, it is the same unknown number we are using to divide all these three numbers. And if so, this means that this unknown number is a common factor to 128, 144 and 192. And you have to find out the greatest number or the greatest common factor, which when used like this will give you remainders, that is 2, 6 and 8. So here what you have to find out, you have to find out the highest common factor for 128, 144 and 192. So what is the first step you have to do? First you subtract the respective remainders from the numbers and you get these three numbers. Then you have to find out the HCF of the three numbers. So this is how you should go about this question. I hope the explanation is clear to you. Now let's see the next question. It says there are two containers containing 24 liter and 60 liter of paint respectively. The paint has to be filled into cans. Find the maximum capacity of the can used such that the paint from both the containers is emptied completely into the cans without mixing them. So here what is mentioned in the question? There are two containers of paint and in one container there are 24 liters of paint, whereas in the other container there are 60 liters of paint. So here you are asked to find out the maximum capacity of a can which can be used to completely divide these two capacities. So what you are actually asked to find out? You are asked to find out a common factor which can divide both these numbers. So when it says the maximum capacity, it means that the highest common factor which can divide these two capacities or these two quantities completely. So that means you are asked to find out the HCF, the highest common factor of 24 and 60, and that will give the maximum capacity of the can that can be used here. So find out the HCF. You can use either the prime factorization method or the short division or common division method to find the HCF. So if this is clear to you, let's discuss how to go about the next question. So the next question 11, it says rectangular tiles of dimensions 15 cm by 10 cm, 20 cm by 10 cm and 25 cm by 10 cm are available in a shop. What is the minimum length of a square hall in which one can place all the three types of tiles separately without breaking them? So what is mentioned in the question? You have three types of tiles in a shop. The first type is of 15 by 10 cm. It means the length is 15 cm whereas the breadth is or the width is 10 cm. The next type is of 20 cm by 10 cm whereas the next type is of 25 cm by 10 cm. So you have three types of tiles in that shop. You are asked to find out the minimum length of a square hall where you can use these three type of tiles, but you have to use them separately and you should not break the tiles also. So how do you find out that minimum length of the square hall or one side of that square hall? Because if it is a square hall, all the sides will be of the same length. So let's see how to go about this question. So if in the square hall, you are going to arrange these tiles in rows of one tile. So imagine In the first row, you are arranging tiles of 15 centimeter. So when you put one tile there, that is 15 centimeter of length. When you put the next tile adjacent to it, the total length would be 30 centimeter. And when you put the next, the total length would be 45 centimeter and so on. So it seems that when you arrange the first type of tile in a row, the length is getting increased in multiples of 15. Similarly, when you arrange the next row, imagine that you are using the next type of tile in the second row. So if you are using the tile with the dimensions 20 by 10, the length in that row will be increasing in multiples of 20. And imagine in the third row you are using the tile of the type 25 by 10. There the length will be getting increased in multiples of 25. And so in the first row you have the tile of dimension 15 by 10. In the second row you have a row of tiles of dimension 20 by 10, and in the third row you have the row of tiles with dimensions 25 by 10. So can you imagine, in the first row the length increases in multiples of 15, whereas in the second row the length increases in multiples of 20, and in the third row the length increases in multiples of 25. And when there is a common multiple, it means that the three rows or the rows will have the same length. So which is that minimum common multiple or the least common multiple? So you see, when you have 20 tiles of dimension 15 by 10 are arranged in a row, you get a length 300 centimeter. And when you arrange 15 tiles of dimension 20 by 10, you get a length 300 centimeter in that row. And when you arrange 12 tiles of dimension 25 by 10, you get a length of 300 centimeter in that row. So the number of tiles differ, but we are not breaking the tiles and we get the same length, and this is the minimum length where we can have the same length for all the rows. So if you think like this, the minimum length on one side possible is 300 centimeter. And if you use the same length on all the sides, you get a square there. So this 300 is a common multiple in these three cases, and you can see it is the least common multiple of these numbers. So what you are doing here, you are finding the least common multiple of the lengths of each tile here. And the least common multiple is the minimum length possible for a square hall, where you can use these three tiles without breaking them. I hope this is clear to you. Now we will see the next question, question number 12. The length, breadth and height of a water tank are 400 centimeter, 320 centimeter and 480 centimeter respectively. Suggest the dimension of a square tile of maximum size that can be fixed on all the sides of the tank without breaking it. So let's see how to go about this. So in the question it says there is a water tank and we are given the dimensions of the water tank, and the length of the water tank is 400 centimeter and it has a breadth of 320 centimeter and the height is 480 centimeter respectively. We are asked to find out the maximum size of a square tile that can be fixed on all the sides of the tank without breaking it. See, for example, if we place one such square tile at a corner like this, the length is getting divided. If we keep on placing the square tiles like this, the length gets divided again and again, or the length is getting factorized. So the same tile, if we keep on placing it like this, see, the height is getting divided equally, or the height is getting factorized. When you keep on placing the square tiles to cover the whole tank, the length, breadth and height, all these three are getting divided in terms of the same length, or the length, height and breadth. These three are getting factorized by the same factor. So that means it's a common factor, and you are asked to find out the maximum size of such a square tile. So this common factor should be the maximum, or it should be the highest common factor. So that highest common factor will divide the length, breadth and height of the tank in terms of the same measure. So here we have to find the highest common factor of these three measurements here. That is, you have to find the HCF or the highest common factor of 400, 320 and 480, and that will give you the maximum size or the maximum length of the side of such a square tile here. So I hope now you know how to go about this question. So these were the questions from exercise 4.4. So complete all the questions in your notebook. You can submit your answers in Microsoft Teams. Also, there are two more questions given right after exercise 4.4. One is based on value education, the other one is about life skills. So please go through these two questions also and do accordingly. So that's all for today, children. We'll meet in the next class with a new topic. Till then, bye.